Hi everyone. Today's lesson is on measures of central tendency. Another word we use for that is average. But there's not just one type of average. There's three that we focus on. So keep that in mind as we go through. A measure of central tendency is a single number that summarizes an entire set of data. The mean is one measure of central tendency. It's what we typically refer to as the average. But the median and mode, which we'll also talk about, can also be referred to as the average. So something that one of my classes talks about that we won't in here, but is the fact that you may see statistics on TV or from an employer or whatever, and they might say average, but you don't know which average they've used. So it can sometimes be deceiving if they aren't specific. Anyway, the mean, or the arithmetic mean, however, either way, is a set of data values given by this formula. You add up all the data values and then divide by the number of data values. So example 1 says, an airplane mechanic was asked to prepare an estimate of the cost for annual inspection of a small Bonanza aircraft. The mechanic's records showed that 8 prior inspections on the same type of plane had required these amounts of times. Find the mean inspection time. So, the mean is the sum of all the data divided by the number of data values, and there are 8. So the sum is 81.4. We divide that by 8, and we get 10.175. And we're going to round that to 2 decimal places, 10.18 hours. Most scientific calculators have special stat and data functions that allow you to enter data and calculate statistical measures. Before using these, you should be able to set them up and do them the long way, though. Another commonly used measure of central tendency is the median. The median of a set of data values is the middle value. Now, it's not just the middle of the list. You have to order them from smallest to largest and then take the middle value. So for example 2, it says a machine shop produces 7 copies of a steel disc. The thicknesses of the discs are measured by a vernier caliper or in inches. Those data points. I'm not going to read them all out. It'd take forever. Find the median thickness. So we have to start by listing them in order. So let's see. This is the smallest one, and I'm going to kind of mark them out as we go so I don't repeat any. And then 1.738. There's another 1.738, so we have to list both of them. 1.739. And we'll finish up with 2 1.740s and a 1.741. So the middle value, we just count. We've got 1, 2, 3, there it is. So the median is 1.739. What if you had an even number of data values? So let's take this same data and get rid of one of them. So then you end up with 2 in the middle. So what you do is you take those two numbers and average or divide them by 2. Add them and divide by 2. So 1.7385. Median and mean are mostly used, but you could use the mode. The mode of a set of data is the value that occurs most often in the set. So sometimes there won't be a mode. If there's only one of each data point, then you wouldn't have a mode. In example 3, an airplane mechanic, same thing, find the mode inspection time. So let's see. Are any of these listed more than once? Looks like 10.8 is. So the mode is 10.8 hours. Frequency distributions. In a frequency distribution, data values are often placed into groups of the same size. These groups are known as classes, and the number of values within each class is tallied. The result of each tally is called the frequency of that class. We define class width as the difference between the lower limits of the 2 consecutive classes. And you want your class widths to all be the same. Consider the following data values representing the number of hours during 1 week that a group of drafting students spent working on the conception, design, and modeling of a crankshaft. Construct a frequency distribution. So, we need to determine what our class size should be. We're going to start with what's the smallest data point here. Is it 13, I think? So we'll start with 10. And then the largest, I think it's 73. That's close anyway. We'll be up to 73. Or we'll go up to 79 because that's just before 80. So we're going to have 10 starting and ending with 79. And we've got 1, 2, 3, 4, 5, 6, 7 spots here. And so if we take 79 or 80 to make it easier and subtract 10 and divide by our 7 spots, then we get that each class size will be 10. So starting with 10 and going to 19, that's 10. That's 10 is the width of that class. And so each width will be the same. We'll do 20 to 29. I'm going to do different colors. $30 to $39, $40 to $49, $50 to $59, $60 to $69, and $70 to $79. And so we start tallying up how much of each of these there are. So between 10 and 19, we go through, and I'm not going to do all of these, but there's a 16, a 15, a 13, a 17, a 16, and I think I've missed one somewhere. 19. So the frequency is 6. Between 20 and 29, there's 1, 2, 3, 4, 5, 6, 7, 8. And let's do one more. Between 30 and 39. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we just finish up. Between 40 and 49, there's 7. Between 50 and 59, there are 4. Between 60 and 69, there's 2. And between 70 and 79 are 1. And so that's a frequency table, or a frequency distribution. What if you aren't given all the data, but you're given a frequency distribution? How would you find the mean? Well, there's several different steps here, and I'm not going to read them. We're going to go through the example using our steps. So find the mean number of hours worked on the crankshaft design. So we're assuming that we didn't have that list and couldn't add them up. Okay, exactly. We just had the frequency table. So what we do says the first step is find the midpoint of each class by calculating the mean of the endpoints in the class. So the midpoint of the first class would be 10 plus 19 divided by 2. That's 14.5. The midpoint of the second class would be 20 plus 29 divided by 2. That's 24.5. Can't really see my decimal there. Then we'd take 30 plus 39 and divide by 2. Get 34.5. You might be starting to see a pattern here. 40 plus 49 divided by 2. 44.5. And so the next one would be 54.5. 64.5 and 74.5. Okay? It says multiply each frequency by its corresponding midpoint. So we'll take 6, the frequency, times 14.5 and get 87. For the second one, 8 times 24.5, we get 196. For the third, 12 times 34.5, we have 414. And for the fourth, 7 times 44.5 is 311.5. And then 4 times 54.5 is 218. 2 times 64.5 is 129. And 1 times 74.5 is just 74.5. Third, find the sum of the frequencies. So we're going to add 87 plus 196 plus 414 plus 311.5 and so forth, and get the sum to be 1,430. Then find the sum of the products from step 2. Step 3 was find the sum of the frequencies. So the sum of the frequency was, Trying to find a different color. Can't find one. That gives us N, and that would be 40. And then we find the sum of the products, which we've already done. And last, divide the sum of the products by N. So we'll take 1430 divided by 40 and get 35.75, or about 35.8 hours. And note that the mean of group data is not necessarily equal to the mean of the ungrouped data. Okay, if we went and added those up and divided by the number of them, it wouldn't necessarily be the same, but it should be close. And that concludes our section. Pretty short one.